In a previous video, we used some rather complex formulas to get a unique drop-down list that's fully dynamic. Now the challenge was that the data had multiple instances of each name. And these names were also not grouped together. So they were just like randomly on this list. Here's how it looked. I'm also going to add the link to that video in the descriptions. We also used Excel's table feature to be able to add more names and have them reflected on our drop-down list. Then the next question came on how could we create the second drop-down that's dependent on the first drop-down and based on the same messy dataset. So for example, if we select productivity from this list, we want to see all the apps that belong to productivity. If we select games, we want to see all the apps for games and so on. So let's see how we can set this up with a formula that doesn't require Control-Shift-Enter. Let's just take a look at the data set that we have. Division is listed here. It's random. They're not grouped together. We have the apps listed in front of the division. I've created a table out of this called table div. In a previous tutorial, we solved for getting a unique list out of the division. So in this case, we just have 3 divisions here. If we got new divisions added to this list, our data preparation table, which was actually the driver for this dropdown, would update automatically. As a result, our dropdown updated automatically because behind this there's the offset function. Now, if you missed that, the link to it is in the descriptions. But in addition to this, I really recommend that you watch the video from Kevin Lerbas, where he included many different ways of getting the same thing done. So if you have a huge data set and this formula approach could be a bit slow for you, I do recommend that you check out your other options from that video. And I'm going to add the link to that as well in the descriptions. This video is for those people who are interested to see how you can get the dependent drop-down part also with formulas. Okay, so right here, we're going to have the apps that belong to the game utility. And if we switch to productivity, we're going to have the apps that belong to productivity. So my approach here is very similar to what we did to solve for this one. I'm also going to use a data preparation table and get the list of apps in the data preparation table and then make a drop down based on that. This data preparation table will look slightly different because it's going to be going this way instead of vertical, right? But that doesn't pose any problems for the data validation, right? If we go to data validation and we select list, it doesn't matter if our list is vertical or horizontal, it's still going to show it to us in a vertical manner, right? So if we manage to put our list in a horizontal way in front here, and then we also use a similar function like offset to get the correct list shown, then we've solved this problem. Next challenge to solve for is the formula that we need for this. And I mentioned that I want to use a CSE-free version of a formula. So this means I have a choice between index, maybe some product, maybe the aggregate function. So since I used index here, and index is going to work well with getting the answer from the app column, I'm also going to use index in here, right? Because if I manage to find the row that the apps are sitting on based on the division here, then I'm all set. Remember, what the index function needs is first is the map and then how many rows it should go down, right? So if it checks that this is productivity and it notices, okay, the first occurrence here is in position 1, then I have my answer. Second occurrence, position 2, third, position 3, and then it needs to skip position 4 because the next occurrence is actually in position 5, right? So the challenge for the index function here is to find the correct row number. I'm just going to put the rows that we would need for productivity, for example, in here, just so that we can double check our formulas later. So that would be 1, 2, 3, and 4 is not a match, right? Because 1, 2, 3 is a match. This one is game, right? So for productivity, this will not be a match. Then we need 5, and then we need 6, and 7 is not a match, and then we need 8. Okay, so something like this is a sample data set that we can compare to when we manage to come up with a formula that gives us these numbers. So what formula could we use that is also CSE free? I can think of the aggregate function, because inside aggregate you have this part here that can handle arrays. I would probably go with small to get the apps shown in the same order that I see here. Right? And the good thing with the aggregate function is that you get these additional options of ignoring error values, and that's something that could come in handy. When we also select small and we put in our array, the last argument is if we want the smallest, the second smallest, third smallest, and so on. And that's something that we can also make dynamic. But even if we have an idea about the formula that could work, the challenge is to get this array part right. That is going to give us these numbers inside the array. Okay, so let's start with the core first. Let's look at how this array could look. I need to check if division, okay, and I'm just going to click on top to get the whole column of the table, if division equals this. Okay, I'm just going to press enter. Now, this is an array formula all written in one cell. To see what's really behind it, we need to click in the formula bar and click on F9. Let me just expand this so we can see the whole data set. We see that for the first occurrence is true, 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 false, true, right? So that's exactly what we see here. Now it would be great to translate these to row numbers. So I'm going to press Ctrl Z to go back to my formula and multiply this with the row that they're sitting on. Okay, but I'm just going to put this in brackets. And now let's press F9. We see now the associated row number of productivity, right? So 4, 5, 6, then it's 0 because there's no match there, 8, 9, 0, and so on. That's good, but if we're planning to use small on this data set, then small is going to always find all the zeros, right? We want to get rid of the zeros, and best would be, since aggregate can ignore errors, that we actually generate an error wherever we have zeros. To do that, we can divide this, which is the result of our true and false values, with itself, and then multiply it with the row. Why? Because if we divide a true with a true, we're dividing a 1 with a 1, we get 1. If we divide a false with a false, we're going to get an error because we're dividing 0 with a 0. Right? So if I just highlight this and press F9, you can see 1, 1, error, 1, 1, and so on. Now if we multiply this with the row, we should get the same thing, but have the zeros replaced with errors. Okay, so we're on a good track. Since we're planning to feed these later on to the index function, if we're indexing this area, we need to start with 1, 2, 3, and so on. We need to make a correction to these numbers so that they also start from 1 here. Okay, so I'm just going to press Ctrl Z to go back, and I need to deduct the header row. So I'm just going to click on this one right here, close bracket, and since we want this result to be then multiplied with this one, I have to put the whole thing in its own brackets. Okay, so now let's check. 1, 2, 3, error. 5, 6, very good, then it's 8. Now we're on the right track. We can plug this in the aggregate function, but let's just think about the fixing as well, because I'm planning to pull this across and pull it down as well. So I don't want this E8 to move. So I'm going to fix that, but I do want it to move down, right? So I just need the column to be fixed here as well. The rest are table references. So let's see how they behave later on when we pull this across and down. Let's plug this in our aggregate function as the array part. We're going to go with number 15, which is for small. Then we're going to ignore errors. Now you can also pick 6 or pick 3, which ignores also hidden rows. Then we want our array, which is this. Then after this, we want our case. So if it wants the one smallest, basically the smallest, or the second smallest, third smallest, and so on. We want this number to change when we're dragging this across. So here we can use the columns function and just take a look at the column above and fix the first cell reference. The second one I can leave as is, but if I don't want it to come down, I can also just fix the 7 and leave the column variable. Okay, but that doesn't matter. You can also leave it fully variable. That should take care of the aggregate. Let's just check what happens if we pull this across. Okay, so this looks good, this looks good. These don't look so good. So what's happening here? It shifted to the app. What's happening here? It shifted back, right? So tables behave in this way that when you're pulling it across, your column reference is also going to move. And then when the table ends, because it can't move anymore, it's going to go back. But we don't want that. We want to fix the column reference to division. And fixing in tables means that you need to get that square bracket header part and do a colon and then reference it again. So it's like division to division. Kind of like when you reference an entire column, like for this one it would be K to K. It's the same, except that you can't leave the formula like this because there is an error in here. It doesn't accept it. You need to put them in square brackets again. So that whole reference in square brackets. So now I can leave it. The main challenge here is to find your square brackets on the keyboard. I'm just going to update all of these ones that need the fixed referencing. For the header, since I'm only interested in the row number, if the header switches to here and back, it doesn't matter. Okay, I can let that switch. Now if you pull this, it looks good. It's exactly the numbers that we want. So now we should be able to plug this inside an index function. We need to index app here because our answer is an app, but again, we don't want it to move back and forth. So we need to make sure that we have a fixed header here and do this special referencing with the square brackets. And that's it. And let's close the bracket there and see what we get. Okay, let's just check these. Vencal, blend, voltage, twister skipped, inky, Sleops, kind ape, and so on. Okay, so that looks really nice. But now the thing is that if we add more productivity apps to this, we want our formula to pick it up. So we do want to leave enough space here, just like we left enough space here to account for new divisions. So I'm going to pull this across until where I think I might have apps being added. Okay, so I'm going to go until here. Now we get errors wherever it doesn't find anything, and we can correct for these errors. Instead of using if error, let's do a count. We can count how many productivities we have on this list, and we'll make sure that the moment our columns are more than this count, we're just going to write nothing to the cell instead of the error. Let's just use this helper cell here and do a count if our range is division and our app is this one. Okay, so I'm just going to pull this down. That's the count. So let's add our if to this. If the columns here, we can just copy this formula, is less than or equal to our number here. And again, let's think about the fixing. We have to just fix the column, but not the row. Then it should do the index thing. Otherwise, it should do nothing. Now let's check. Looks good. And the real challenge is to make sure everything else updates as well. these look good as well. So I can get rid of this helper one. Now that I have my app list here, I just need to create a dependent dropdown. Here I will also use the offset function, just like I did here, except that it's going to have a bit of a twist to it. We need to figure out which row our list is sitting on and how many columns our row has. We can fix the columns to 20, for example, in this one, but we'll just see the last ones, the last places, as empty on our list. And you'd probably want to restrict that to just the number of apps that you have on the list, right? So let's see how we can overcome these challenges. I'm going to type the formula for the validation list in here first, and then we can copy it to the validation. It's just easier to track. So offset, our starting cell can be this one. I'm going to fix it. Then how many rows do we want to move down? So which list do we need? Well, that depends on our first selection, right? So I can match for this one, and I'm going to fix it in this list, fix it again, and I want a perfect match. And for the columns, how many columns do we want to move? Well, we don't want to move any columns. We want to include all the columns. Including all the columns is the width argument of offset. For the column argument, since we don't want to move anything, we can skip it. Height is 1. That's an optional argument. We can skip it. Width is how many columns do we want included. So the easiest approach is to accept those empty ones and just put 20 in there. Okay, so if I click on this and press F9, I can see the list and I see the empty ones. So Control Z to go back. But the better approach is to also restrict this. Now the formula that I came up with to restrict this is a combination of COUNTIF and offset. And since this video is already getting too long, I'm not going to explain this in this video, but I'll create a second video on just this concept, how you can restrict your data validation lists to the number of categories that you have in a separate video. And I'll try to get that out in the next month or so. Okay, for now, I'm just going to paste the formula in. That's the formula. If I click here and press F9, we can see that now it's restricted to our list. Let's fully test this by copying this and pasting it in the data validation box. Go to Data, Data Validation, click on List, and paste this in. Now let's just double check. Vencal blend. Let's just compare this to our original list as well. Okay, that looks good. If I change this to game, that's Twister, Fighter, Hacker, that looks good as well. Okay, so one last check is adding stuff to this table. Let's add a new game to this, and let's call it Rocket. And also, let me just add a full new division and call the app Hello. Okay, so they pop up here. Rocket has popped up as well. So I'm already in game. Let's just check. Rocket is right there. Let's see if we have the new one. And Hello is right here. That's how you can create a dependent drop-down list on an unsorted table like this one. Now, it's a bit complex to set this up, so feel free to download the workbook and use it as your template. As always, if you like this video, don't forget to give it a thumbs up. And for more videos like this one, don't forget to subscribe to this channel so that you can get updates when new videos come out.